Good morning, grade 8s. Class test 2C live memo. We have 1.1. The instruction is use the laws of exponents to simplify the following. Leave your answers in exponential form. So same instruction that we've been dealing with over the past couple of questions since class test 2B. And our problems here are starting to get more complex. So in 1.1.1 we have a fraction 5 to the power 3 times 5 to the power 2 over or divided by 5 to the power 4. So like I said previously, when you are dealing with a fraction or faced with a fraction, whether it's using laws of exponents or in algebra, which will basically be the same thing for you for now, you need to assess the numerator and denominator individually and see if you are able to simplify them individually before you start to divide or try to divide. So the division comes last. The division then only happens when my numerator and denominator are simplified fully. Now in this case, my numerator, it is not simplified fully because I can still simplify those two powers and make them into one power. If you look at your denominator is simply 1 power of 5 to the power 4, so nothing can be done there. But we can then go back to our numerator and say, well, I've got 5 to the power 3 times 5 to the power 2. I can keep my base, which is the same 5, and I can add my exponents, 3 plus 2. And that is all over 5 to the power 4. And this is pretty straightforward. We've got 5 to the power 5 divided by 5 to the power 4. And we are now dividing the two powers that have the same base. So the law says that if I've got two powers of the same base being divided, I can keep my base and subtract my exponents. So that will just result in 5 to the power 1, which of course is just 5. Now in this type of problem, I've noticed that a lot of you just, go ahead and calculate this using a calculator because these are all numbers and I can simply punch it into a calculator and eventually I will arrive at the answer of 5. However, the instruction is use your laws of exponents to simplify the following. And of course, when you get to problems like over here, 1.1.2 all the way down, you will not be able to just use a calculator anymore because now you are forced to use the laws of exponents because they are only letters or variables. So please bear that in mind. Try to approach it like this, where you look at your numerator and denominator separately and try to simplify them using the laws of exponents and not just use the calculator. 1.1.2, we have xy in brackets raised to the power of 0. Now, if you look at this bracket or this power, everything inside the bracket is being raised to the power of 0. So that means everything in the bracket raised to the power of 0 will simply be equal to 1. And that's your answer. And I'll just break away from this quickly. I'll give you a separate example while we are busy with this now. Let's say we have, I'll just use a different color. Maybe we have a 4 in front of this bracket being raised to the power 0. Now, a lot of you still say, okay, this is equal to 1, which is not true because the 4 outside, this 4 is not being raised to the power 0. It is only the bracket that is being raised to the power 0. So I will then have, between the 4 and the bracket, we have multiplication, as we all know. So that is actually 4 times this bracket of xy to the power, or xy to the power 0, yes. So xy to the power of 0 is 1. But the 4 is still being multiplied with that bracket. So, but the bracket is equal to 1, so now it is 4 times 1. So my answer is 4. Because nothing happened to the 4. It was not raised to the power of 0, so it can't be included in your power. So your answer is 4 and your answer is not 1. Let's take another example. So we're not moving on to 1.1.3 just yet. Let's say I have negative 3x in front of this bracket. Let's take the same bracket of x, y to the power of 0. Now this, of course, if I look at this number over here, or this product, it is being multiplied with the bracket, which is raised to the power 0. And it itself is not being raised to the power 0. So I will keep negative 3x, and it is being multiplied with xy to the power 0, xy to the power 0, and negative 3x is then simply being multiplied with 1, which means my final answer would be negative 3x and not 1, because negative 3x had nothing to do with being raised to the power 0. It is not being raised to the power 0, so it cannot be part of that power, and it is then still just simply being multiplied with whatever comes out of the power, which in this case is 1.